Imagine this. You are floating in complete darkness. No Earth, no stars, no galaxies, just silence. Then suddenly, a tiny spark of light appears. From that spark, the entire universe is born. Billions of galaxies, trillions of stars, planets, oceans, life, and eventually you. Now here is the question that has haunted scientists, philosophers, and humanity for thousands of years. Did all of this happen by accident, or is there something greater behind the universe itself? Is the universe simply the result of random physics? Or is it the fingerprint of something or someone beyond space and time? Tonight we are not approaching this question with religion. We are approaching it as scientists. Through cosmology, physics, astronomy, and the deepest discoveries of modern science. And by the end of this journey, you may see the universe very differently. Chapter 1. The universe is stranger than we ever imagined. For most of human history, people believed Earth was the center of everything. But modern astronomy shattered that illusion. Our planet is just a tiny rock orbiting a star. That star, the Sun, is only one of hundreds of billions of stars in our galaxy, the Milky Way. And the Milky Way itself is only one galaxy among more than 2 trillion galaxies in the observable universe. Let that sink in. 2 trillion galaxies. Each galaxy containing billions or trillions of stars. This means the universe contains more stars than all the grains of sand on Earth. Now here's where things get even stranger. When astronomers measure the universe, they discover something shocking. Only 5% of the universe is normal matter. Everything we see, stars, planets, gas, dust, humans, all of it makes up just 5%. The rest, 27%, is dark matter, and 68% is something even more mysterious called dark energy. Scientists still don't fully understand either of them. In other words, 95% of reality is still unknown. So the first lesson science teaches us is humility. The universe is far more mysterious than we ever imagined. Chapter 2. The moment everything began. Modern cosmology tells us the universe began about 13.8 billion years ago in an event known as the Big Bang. But here is what most people misunderstand. The Big Bang was not an explosion in space. It was the creation of space itself. Time began, space began, matter began, energy began. Before that moment, there was no universe. This raises one of the most profound scientific questions ever asked. Why did the universe begin at all? Physics can explain how the universe evolved after the but explaining why the Big Bang happened is much harder. Some scientists suggest quantum fluctuations created the universe. Others believe multiple universes exist in a cosmic multiverse. But even these theories raise another question. Why do these laws exist at all? Why is the universe governed by mathematical rules? As the legendary physicist Albert Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." Why should the universe follow elegant mathematical laws? Why should human minds be able to understand them? These questions lie at the very edge of science. Chapter 3. The Fine-Tuned Universe. Now we arrive at something that has shocked many scientists. The universe appears to be extremely fine-tuned for life. If certain physical constants were even slightly different, life would be impossible. For example, if gravity were slightly stronger, stars would burn too quickly. If it were weaker, stars would never ignite. If the electromagnetic force were different, atoms could not form. If the cosmological constant were slightly larger, galaxies would never form. Physicists have calculated that many of these constants must fall within incredibly tiny ranges. Some estimates suggest the odds of such precise tuning are as unlikely as 1 in 10. To understand how absurdly precise that is, imagine a dartboard the size of the entire observable universe. Now imagine throwing a dart and hitting a target smaller than an atom. That's the level of precision involved. This phenomenon is known as cosmic fine-tuning. Some scientists argue this could suggest a designer of the universe. Others believe it may simply be the result of countless universes in a multiverse. But currently, there is no direct evidence for other universes, which leaves the mystery open. Chapter 4: Consciousness, the universe becoming aware. Now consider something even stranger. You are made of atoms forged in ancient stars. Every carbon atom in your body was created inside exploding stars called supernova. In other words, the universe literally created the ingredients needed for life. Then life evolved. Then brains evolved. Then consciousness emerged. And now the universe is able to observe itself through you. The astronomer Carl Sagan once said, "We are a way for the cosmos to know itself." But this raises another deep mystery. What exactly is consciousness? Even today, neuroscience cannot fully explain how subjective experience arises from neurons. Why does matter become aware? Why does the universe produce observers? Some physicists believe consciousness may be a fundamental property of reality itself. Chapter 5: The Silence of the Universe. If the universe is so vast, why haven't we found alien civilizations everywhere? This puzzle is known as the Fermi paradox. Given billions of planets in the galaxy, intelligent life should be common. Yet the universe appears silent. Some scientists believe intelligent civilizations are extremely rare. Others believe they destroy themselves before spreading. But another possibility exists. Perhaps the conditions required for conscious life are so precise that they are incredibly rare, which again returns us to the mystery of cosmic fine-tuning. Chapter 6: What Science Can and Cannot Answer. Science is incredibly powerful. It can explain how stars form, how galaxies evolve, how black holes bend space. It has even allowed us to detect gravitational waves and photograph a black hole. But science has limits. Science answers how questions, but questions like these are different. Why does the universe exist? Why are there laws of physics? Why does anything exist at all? These questions may lie beyond pure scientific measurement. They enter the realm of philosophy and metaphysics. Chapter 7: The Astronomer's Perspective. Many scientists throughout history have wrestled with this mystery. Isaac Newton believed the universe reflected divine order. Einstein spoke about a cosmic intelligence. Others believe the universe requires no creator. Modern science does not prove God, but it also does not disprove God. Instead, it reveals something profound. The universe is far more mysterious than we once believed. Chapter 8. A different way to think about God. Sometimes when people hear the word God, they imagine a human-like figure controlling the universe. But some scientists propose a different idea. What if God is not a being inside the universe, but the source of the universe itself? Something beyond space, beyond time, beyond physical laws. After all, if space and time began with the Big Bang, then whatever caused the universe must exist outside space and time, which is a concept many philosophical traditions have described for centuries. Chapter 9. The Cosmic Question. In the end, the greatest discovery of science may not be answers, but questions. Questions that lead us deeper into the mystery of existence. Why is there something rather than nothing? Why does the universe follow elegant mathematical laws? Why does consciousness exist? And why does the universe appear capable of creating life? These questions remain open. Tonight, when you look at the stars, remember something incredible. Those stars are not just distant lights. They are ancient furnaces that created the atoms inside your body. You are not separate from the universe. You are part of it. The universe created you. And now, you are asking the biggest question the universe has ever asked about itself. Why do I exist? And maybe, just maybe, the search for that answer is the greatest journey humanity will ever take. Chapter 10. The Birth of Space and Time. To understand the question of God through science, we must return to the very beginning. Not just a beginning of matter, but the beginning of reality itself. According to modern cosmology, space and time began together during the Big Bang. Before that moment, there was no before. No clocks. No distance. No space for anything to exist. Imagine trying to ask, what is north of the North Pole? The question itself becomes meaningless. Similarly, asking what existed before the Big Bang might not even make sense within our current understanding of physics. But this leads to a stunning implication. If time itself began with the Big Bang, then whatever caused the universe must exist outside time, outside space, outside the physical universe. Some physicists call this the ultimate boundary of science, because our equations break down at that point. Even theories like quantum mechanics and general relativity struggle to describe that first moment, which is why scientists today are searching for a deeper theory that can unite them. Chapter 11. The Quest for the Theory of Everything. For decades, physicists have searched for what they call a theory of everything, a single set of equations that explains every force in nature. Gravity, electromagnetism, strong nuclear force, weak nuclear force. One of the most famous attempts is string theory. According to this idea, the fundamental building blocks of reality are not particles. They are tiny vibrating strings. Different vibrations create different particles. Electrons, quarks, photons, all just different musical notes played by the universe. If true, the universe would be like a gigantic cosmic symphony. But here is the strange part. The mathematics of string theory suggests the universe may contain extra dimensions beyond the 3 dimensions of space we experience. Some versions propose 10 or even 11 dimensions. Dimensions curled up so small that we cannot detect them. This raises a fascinating possibility. What if reality is far deeper than our senses can perceive? Chapter 12. The Multiverse Hypothesis. Another idea that has gained attention among physicists is the multiverse. The concept suggests our universe might be only one of many universes. Each universe could have different laws of physics, different constants, different realities. Some universes might collapse instantly. Others might expand forever. Only a few may allow stars, planets, and life to exist. If this idea is correct, then our universe may simply be one lucky universe among countless others. But there's a major problem. So far, we have no direct evidence that other universes exist. The multiverse remains a hypothesis, a fascinating one, but still unproven, which leaves the mystery unresolved. Chapter 13. The Mathematical Universe. One of the strangest discoveries about reality is how deeply it follows mathematics. Galaxies move according to equations. Light travels according to equations. Even black holes obey precise mathematical rules. The theoretical physicist Stephen Hawking once asked a profound question. Why does the universe obey mathematics at all? Why should reality be describable with numbers and equations? Why should the universe behave like a perfectly structured system rather than chaotic randomness? Some scientists believe mathematics is simply the language we invented to describe nature. Others believe mathematics is something deeper, something fundamental to reality itself. Perhaps the universe is not just described by mathematics. Perhaps the universe is mathematics. Chapter 14. Black Holes. The Edge of Reality. Now let's travel to one of the most mysterious objects in the universe. Black holes. These objects form when massive stars collapse under their own gravity. Their gravity becomes so powerful that not even light can escape. The boundary surrounding a black hole is called the event horizon. Cross that boundary, and there is no return. At the center lies something even stranger, a singularity, a point where gravity becomes infinite and the known laws of physics break down. Some physicists even speculate that black holes could create new universes. If that were true, our entire universe might exist inside a black hole in another universe. It sounds like science fiction, but mathematically it's not impossible. Chapter 1.5. The Possibility of a Cosmic Mind. As science explores deeper layers of reality, some thinkers have proposed an unusual idea. What if consciousness is not just a product of the brain? What if consciousness is a fundamental property of the universe? This idea is sometimes called panpsychism. It suggests that awareness may exist in some form throughout the universe, not necessarily in the way humans experience it, but as a fundamental aspect of reality. If this were true, then consciousness would not simply appear randomly. Instead, it would be woven into the fabric of existence itself. This concept raises an extraordinary possibility. What if the universe itself is a kind of cosmic mind? Chapter 16. The Limits of Human Understanding. Despite centuries of scientific progress, the truth is this: we still understand only a tiny fraction of reality. Remember earlier, 95% of the universe is made of dark matter and dark energy. We do not know what they are. We do not know why the universe exists. We do not know why the laws of physics exist. We do not even fully understand consciousness. Science is incredibly powerful, but it is also a journey. Every discovery opens new mysteries. Chapter 17. What astronomers feel when looking at the universe. When astronomers observe the cosmos through powerful telescopes, they experience something extraordinary. Not just scientific curiosity, but awe. The images captured by the James Webb Space Telescope reveal galaxies forming billions of years ago. Ancient light traveling across the universe for unimaginable distances. Stars being born inside glowing nebulae. Massive black holes shaping galaxies. These observations remind us of something profound. We live inside a universe of staggering beauty and complexity. A universe that somehow produced conscious beings capable of understanding it. Chapter 18. The Ultimate Question. So, does God exist? Science cannot give a final answer. What science can tell us is this: the universe had a beginning. The universe follows precise mathematical laws. The universe appears finely tuned for life, and consciousness emerged from cosmic matter. Some people interpret these facts as evidence of a creator. Others believe they are simply natural processes we do not yet fully understand. Both views exist within the scientific community. Perhaps the greatest lesson science teaches us is humility. We are a young species on a small planet orbiting an ordinary star inside the Milky Way. Yet somehow, we have begun to uncover the story of the cosmos. But the biggest questions remain unanswered. Why does the universe exist? Why are the laws of physics the way they are? Why does consciousness exist? And is there something beyond the universe itself? Maybe the answer will come through future discoveries. Or maybe the mystery will always remain. But one thing is certain. The universe is far more incredible than we ever imagined. And the search for truth has only just begun. Chapter 19. The First Light of the Universe. For hundreds of thousands of years after the Big Bang, the universe was completely dark. No stars, no galaxies, no planets. Just a hot fog of particles. Then something extraordinary happened. Gravity slowly began pulling matter together. Tiny fluctuations in the cosmic gas started collapsing. And finally, the first stars ignited. These first stars were enormous, sometimes hundreds of times larger than our sun. They burned incredibly bright, and inside their cores they created the first heavy elements in the universe: carbon, oxygen, iron. Every atom that makes up your body today was forged inside ancient stars billions of years ago, which means something remarkable. You are literally made of stardust. Chapter 20. The Emergence of Complexity. At first, the universe was simple, just hydrogen and helium. But as stars lived and died, the universe slowly became more complex. When massive stars exploded as supernova, they scattered heavy elements across space. These elements formed new stars, new planets. Eventually, the right conditions appeared for chemistry to become biology. On one small planet orbiting an ordinary star, something incredible happened. Life emerged, from simple molecules to cells to complex organisms, and finally to intelligent beings capable of asking questions about the universe itself. Chapter 21: The Rare Planet Hypothesis. Astronomers have discovered thousands of planets orbiting distant stars. Many of them are Earth-like, but having a planet similar to Earth may not be enough for life. Life requires a long chain of extremely rare conditions. A stable star, the right distance from that star, liquid water, a protective atmosphere, a magnetic field, a large moon stabilizing the planet's tilt, plate tectonics recycling carbon. Some scientists call this the rare Earth hypothesis. It suggests that complex life may be extremely uncommon in the universe. If that is true, then conscious life may be one of the rarest phenomena in existence. Chapter 22: Intelligence, a cosmic accident or destiny. Even if life begins on a planet, intelligence is not guaranteed. For billions of years, Earth was dominated by simple organisms. Dinosaurs ruled for over 160 million years. Yet none of them built telescopes. None of them studied the stars. Human intelligence appeared only very recently in cosmic history. So here is another profound question. Is intelligence simply a random evolutionary accident? Or is the universe somehow structured in a way that eventually leads to consciousness? Scientists still do not know. But the fact that the universe produced thinking beings capable of understanding it remains one of the greatest mysteries in science. Chapter 23: The Anthropic Principle. Some physicists use a concept called the anthropic principle to explain the fine-tuning of the universe. The idea is surprisingly simple. We observe a universe capable of supporting life, because if it weren't capable of supporting life, we wouldn't be here to observe it. In other words, the universe must allow observers to exist. But this explanation raises deeper questions. Why does the universe allow observers at all? Why does reality permit consciousness? These questions remain unanswered. Chapter 24: Time, the most mysterious dimension. Time feels simple. Seconds pass. Days move forward. But in physics, time is incredibly strange. According to Albert Einstein, time is not absolute. It can stretch, slow down, even stop. Near massive objects like black holes, time moves slower. Astronauts traveling near the speed of light would experience time differently than people on Earth. This phenomenon is called time dilation, which means the universe does not experience time the way humans do. The deeper physicists study time, the more mysterious it becomes. Some theories even suggest time itself might be an illusion emerging from deeper physical processes. Chapter 25: The End of the Universe. Just as the universe had a beginning, it will also have an ending. Scientists believe the universe is expanding faster and faster due to dark energy. If this continues, the universe will eventually reach a state called the heat death of the universe. In this distant future, stars will burn out, galaxies will drift apart, black holes will slowly evaporate. Eventually, the universe may become a cold, dark expanse of empty space. No stars, no light, no life, just silence. This future may occur trillions upon trillions of years from now, but it raises an unsettling question. If the universe ends in darkness, why did it begin at all? Chapter 26. The Cosmic Puzzle. The deeper we explore reality, the stranger it becomes. The universe began from an incredibly precise event. It follows mathematical laws. It appears finely tuned for life. It produced consciousness. And yet, its ultimate origin remains unknown. Some scientists see these mysteries as evidence of deeper physical laws yet to be discovered. Others see hints of something beyond the universe. But right now, the truth is this: we simply do not know. Chapter 27. Humanity's Place in the Cosmos. Despite our small size, humanity has achieved something extraordinary. In just a few centuries, we have begun to understand the universe. We built telescopes that see billions of light years away. We landed probes on distant planets. We detected gravitational waves from colliding black holes. We even captured the first image of a black hole. This is the power of curiosity. The same curiosity that led ancient humans to look up at the night sky and wonder. Chapter 28. The Eternal Question. For thousands of years, humans have asked the same question: does God exist? Science has revealed many secrets of the universe, but this question may lie beyond the limits of pure measurement. It may belong to philosophy, to personal belief, to the way individuals interpret the universe around them. Science provides evidence, but meaning is something humans must interpret. Tonight, when you step outside and look at the stars, remember something astonishing. The atoms in your body were forged inside ancient stars billions of years ago. You are not separate from the universe. You are the universe becoming aware of itself. And maybe the most beautiful part of the story is this: the universe created a species capable of asking the deepest question: why does anything exist at all? And somewhere, hidden in the vast cosmic mystery, the answer may be waiting. Chapter 29. The universe that should not exist. When physicists calculate the energy of empty space, something bizarre appears. According to quantum physics, even a perfect vacuum is not truly empty. Instead, space is filled with tiny fluctuations of energy, where particles briefly appear and disappear. This phenomenon is predicted by quantum mechanics. But when scientists calculate the total energy of empty space, they find a shocking result. The theoretical value is 10 times larger than what we observe in the real universe. This is sometimes called the worst prediction in physics. The observed expansion of the universe is controlled by something known as the cosmological constant. And somehow its value is incredibly small, almost perfectly balanced. If it were slightly larger, galaxies could never form. If it were slightly smaller, the universe might collapse. Why is this number so precisely tuned? No one knows. Chapter 30. The universe as a simulation? Some scientists and philosophers have proposed a radical possibility. What if reality is not fundamental? What if the universe itself is a kind of simulation? This idea is known as the simulation hypothesis. If an advanced civilization developed extremely powerful computers, it might simulate entire universes. Within those simulations, intelligent beings could emerge, and those beings would believe their universe was real. While this idea sounds like science fiction, some philosophers argue it cannot be easily dismissed. If technology continues advancing for thousands or millions of years, simulations of entire universes might become possible. But even if our universe were a simulation, it would raise another question. Who created the simulator? Chapter 31. The Search for Cosmic Signals. For decades, scientists have been listening to the cosmos for signs of intelligent life. Radio telescopes scan the sky searching for unusual signals. This effort is part of the search for extraterrestrial intelligence, often called SETI. If we discovered a signal clearly created by another civilization, it would transform our understanding of life in the universe. It would mean intelligence is not unique to Earth. But despite decades of searching, the universe has remained silent. This silence deepens the mystery known as the Fermi paradox. If intelligent life is common, where is everyone? Chapter 32. The Strange Behavior of Reality. At the smallest scales, reality behaves in ways that seem almost in particles can exist in multiple states at the same time. This phenomenon is called quantum superposition. Even stranger, particles separated by vast distances can affect each other instantly. This phenomenon is known as quantum entanglement. When Albert Einstein first encountered this idea, he famously called it spooky action at a distance. Experiments have repeatedly confirmed that entanglement is real, which means the universe may be connected in ways that defy our normal understanding of space. Chapter 33. The Possibility of Higher Dimensions. Our everyday experience tells us that space has 3 dimensions: length, width, height. But some advanced physical theories suggest there may be more. In certain models of string theory, the universe may contain up to 11 dimensions. Most of these dimensions would be incredibly small, curled up beyond our ability to observe. But if they exist, they could influence the fundamental structure of reality. Some physicists even speculate that other universes might exist in higher dimensions, invisible to us. Imagine entire cosmic realms existing just beyond our perception. Chapter 34. The Mystery of Consciousness. Despite incredible advances in neuroscience, one question remains unsolved. What exactly is consciousness? How does a collection of neurons create subjective experience? Why do we feel emotions? Why do we experience awareness? The astronomer Carl Sagan once reflected on this mystery, noting that humans are the universe becoming aware of itself. Yet science still cannot fully explain how consciousness emerges from physical matter. Some researchers believe it arises purely from brain activity. Others propose that consciousness may be a fundamental property of the universe. If that were true, then awareness might exist at deeper levels of reality. Chapter 35, The Arrow of Time. Another profound mystery in physics is the direction of time. Why does time always move forward? Why do we remember the past but not the future? Physicists refer to this as the arrow of time. The arrow of time is closely connected to entropy, the tendency of systems to move toward disorder. As the universe evolves, entropy increases. Stars burn fuel. Structures decay. Energy spreads out. But why did the universe begin in such an incredibly ordered state in the first place? This question remains unanswered. Chapter 36, The Dark Universe. Earlier we mentioned that most of the universe is invisible. Astronomers have discovered that galaxies move as if they are surrounded by enormous halos of unseen matter. This mysterious substance is called dark matter. Even more puzzling is the force causing the universe to expand faster and faster. Scientists call this dark energy. Together, these two mysterious components make up about 95% of the universe. Yet we still do not know what they are. This means our understanding of the cosmos is still incomplete. Chapter 37, Humanity's Cosmic Future. Despite the immense scale of the universe, humanity has already begun exploring space. We have sent spacecraft to distant planets. Robotic explorers roam the surface of Mars. Telescopes observe galaxies billions of light years away. In the future, humanity may establish colonies on other worlds. Some scientists believe we could eventually explore nearby star systems. Perhaps one day humans will travel beyond our galaxy. And as we explore the cosmos, we may uncover answers to questions that today remain mysteries. Chapter 38, The Philosophical Edge of Science. At the frontier of cosmology, science and philosophy begin to overlap. Physics can describe the evolution of the universe, but deeper questions remain. Why does the universe exist? Why are the laws of physics the way they are? Why does anything exist instead of nothing? These questions may require not only scientific investigation, but philosophical reflection. Chapter 39, The Beauty of the Unknown. Perhaps the most remarkable thing about the universe is not what we know. It is how much we still do not know. Every discovery opens new mysteries. Every answer leads to deeper questions. The universe is vast beyond imagination. And yet, from a small planet orbiting an ordinary star, a curious species has begun to uncover its secrets. Chapter 40, The Final Reflection. As astronomers peer deeper into the cosmos, they are reminded of something extraordinary. The universe is not only vast and ancient, it is also profoundly mysterious. Whether one interprets that mystery through science, philosophy, or spirituality, one truth remains undeniable. We are living in a universe that inspires wonder. A universe capable of producing galaxies, stars, planets, and life. And perhaps the most astonishing part of all is that the universe has produced beings capable of asking the ultimate question: does God exist? For now, science continues the search, and the mystery continues. Chapter 41, The Cosmic Web. When astronomers map the large-scale structure of the universe, something incredible appears. Galaxies are not randomly scattered. Instead, they form enormous structures that stretch across billions of light years. These structures create what scientists call the cosmic web. Imagine a gigantic three-dimensional spiderweb made of galaxies and dark matter. Along the strands of this web lie massive clusters of galaxies. Between them are enormous empty regions known as cosmic voids. This structure is so vast that a single filament can stretch hundreds of millions of light years. And yet, this entire cosmic network formed from tiny fluctuations in the early universe, which raises another astonishing question. How did the universe organize itself into such an elegant structure? Chapter 42, Inflation, the universe's first growth spurt. To explain the structure of the universe, cosmologists developed a theory known as cosmic inflation. According to this theory, a tiny fraction of a second after the Big Bang, the universe expanded incredibly fast, faster than the speed of light. In less than a trillionth of a second, the universe grew from subatomic size to something enormous. This rapid expansion smoothed out irregularities in space while amplifying tiny quantum fluctuations. Those tiny fluctuations later became galaxies, which means the galaxies we see today may have originated from quantum events in the earliest moments of time. In a sense, the structure of the universe may have been shaped by quantum randomness. Chapter 43, The First Galaxies. After the first stars ignited, gravity continued pulling matter together. Clusters of stars formed the first galaxies. Over billions of years, these galaxies merged and evolved into the massive systems we observe today. One such galaxy is our home, the Milky Way. At its center lies a supermassive black hole known as Sagittarius A*. This black hole contains the mass of millions of suns, and yet it is only one of billions of supermassive black holes scattered across the universe. Each galaxy tells a story billions of years long, a story written in stars, gravity, and time. Chapter 44, The Mystery of Dark Matter. When astronomers measure how galaxies rotate, they discover something strange. Stars near the edges of galaxies move much faster than expected. According to gravity, those stars should be flung into space. But they are not. Something invisible is holding them together. This mysterious substance is called dark matter. Dark matter does not emit light. It does not interact with normal matter in ordinary ways. Yet its gravitational influence shapes the entire universe. Without dark matter, galaxies might never have formed, which means the universe we observe may depend heavily on something we cannot even see. Chapter 45, The Accelerating Universe. In 1998, astronomers made a shocking discovery. The universe is not just expanding. Its expansion is accelerating. Something is pushing galaxies apart faster and faster. Scientists call this mysterious force dark energy. Dark energy is thought to make up nearly 70% of the universe. Yet we still do not understand what it is. It may be a property of empty space itself, or it could represent an entirely new form of energy. Either way, it is shaping the future of the cosmos. Chapter 46, The Fate of Black Holes. Black holes seem eternal, but surprisingly, they are not. In the 1970s, the physicist Stephen Hawking discovered something remarkable. Black holes slowly lose energy through a process now called Hawking radiation. Over extremely long timescales, this radiation causes black holes to shrink. Eventually, they may evaporate completely. The largest black holes might take trillions upon trillions of years to disappear. But even the most powerful objects in the universe are not permanent. Chapter 47, The Information Paradox. Black holes introduce one of the greatest puzzles in physics. If something falls into a black hole, its information appears to be lost forever. But according to quantum physics, information cannot be destroyed. This contradiction is known as the black hole information paradox. Physicists have spent decades trying to solve this mystery. Some theories suggest information is encoded on the surface of the event horizon. Others propose radical ideas about the nature of space and time. Solving this puzzle may reveal a deeper theory of reality. Chapter 48, The Holographic Universe. One fascinating idea emerging from black hole research is called the holographic principle. This theory suggests the entire universe may behave like a hologram. In a hologram, three-dimensional information is encoded on a two-dimensional surface. Similarly, the physics inside a region of space might be encoded on its boundary. If this idea is correct, reality may be fundamentally different from how we perceive it. The universe might be more like a projection of deeper information. Chapter 49. Could the universe be alive? Some philosophers and scientists have explored an unusual idea. What if the universe itself behaves like a living system? After all, the cosmos evolves. It forms structures. It produces complexity. And eventually, it produced life and intelligence. Some thinkers have suggested the universe may resemble a self-organizing system, similar to biological evolution. While this idea remains speculative, it highlights how mysterious the cosmos truly is. Chapter 50, The Eternal Mystery. Despite all our discoveries, the universe still holds countless secrets. We have learned about galaxies, black holes, and cosmic expansion. We have mapped the structure of the cosmos and traced its history back billions of years. Yet the deepest questions remain. Why does the universe exist? Why do physical laws exist? Why does consciousness arise from matter? And is there something beyond the universe itself? Science continues to explore these mysteries. But perhaps the most powerful force driving discovery is the same force that inspired humans thousands of years ago. Curiosity, the desire to understand the universe we live in, and the courage to ask the biggest question of all: does God exist? For now, the answer remains part of the greatest mystery in the cosmos. Imagine the most powerful telescope humanity has ever built, suddenly discovering something in space that shouldn't exist. Not a planet, not a galaxy, but an object so strange that scientists begin questioning everything we know about the universe. Right now, the James Webb Space Telescope is looking deeper into space than ever before, almost to the beginning of time after the Big Bang. And what it might eventually see could be the most terrifying discovery in human history, the most powerful telescope ever built. When scientists launched the James Webb Telescope, their goal was simple: look deeper into space, and further back in time. Unlike older telescopes like the Hubble Space Telescope, Webb sees the universe in infrared light, allowing it to peer through cosmic dust and observe the first galaxies ever formed. But sometimes the deeper we look, the more strange and unsettling the universe becomes. Galaxies that shouldn't exist. Soon after Webb began sending back data, scientists noticed something shocking. Massive galaxies appearing far earlier in the universe than theories predicted. These galaxies seemed too large, too organized, too evolved for such an early time after the Big Bang. Some researchers even wondered, did we misunderstand how the universe formed? Or is there something deeper happening behind the scenes of cosmic history? Another terrifying possibility? Evidence of advanced alien civilizations. Webb is powerful enough to analyze the atmospheres of distant planets and detect chemicals linked to life. One day it might observe a distant world and detect something impossible: artificial light, megastructures around a star, or technological pollution in a planet's atmosphere. Signs that we are not alone, and maybe never were. Something older than the universe. But the most frightening discovery of all would be this: something that appears older than the universe itself. A cosmic structure that seems to have formed before the Big Bang. If Webb ever detects something like that, it would force scientists to rethink everything about the origin of reality itself. Because it would mean the universe might not be the beginning after all. But the deeper scientists look into space, the stranger the universe begins to appear. When the James Webb Space Telescope started sending back its first images, astronomers expected to see small, primitive galaxies forming slowly after the Big Bang. Instead, they found something shocking: huge galaxies, bright galaxies, fully formed galaxies. And they existed far earlier than our theories predicted. For decades, scientists believed galaxies took billions of years to grow and evolve. But Webb is showing galaxies that appear too massive, too mature, and too organized for such an early universe. Some researchers have even begun quietly asking a disturbing question. What if our understanding of cosmic history is incomplete? Or worse, what if something influenced the formation of these galaxies long before we thought it was possible? But strange galaxies are not the only mystery. There is something far darker hiding in the universe. Astronomers already know that most of the cosmos is invisible. Stars, planets, and galaxies make up only a tiny fraction of reality. The rest is dominated by mysterious forces known as dark matter and dark energy. These invisible components shape the entire structure of the universe. They control how galaxies move, how clusters form, and how the universe expands. But here is the terrifying part. We still don't know what they actually are. The James Webb Space Telescope may eventually reveal cosmic structures created by this hidden universe-vast formations that have remained invisible until now. Structures so enormous they could stretch across millions of light years. And then there is another possibility that keeps some scientists awake at night. A wandering cosmic monster. In the darkness between galaxies, there may be objects drifting silently through intergalactic space. Objects with gravitational power so intense that they bend light itself. objects like a massive black hole traveling alone through the cosmic void. Imagine something like that moving through the universe for billions of years, undetected, invisible, until a telescope like Webb finally sees it. But perhaps the most unsettling possibility is this. The telescope may discover signs of life beyond Earth. The James Webb Space Telescope is powerful enough to analyze the atmospheres of distant worlds orbiting other stars. By studying the light passing through these atmospheres, scientists can detect gases linked to life. Oxygen, methane, water vapor. But one day, Webb might detect something even more shocking. Artificial chemicals, industrial pollution, or unusual atmospheric patterns that could only be produced by advanced technology. Evidence that an intelligent civilization exists somewhere in the depths of space. And if that moment ever comes, humanity will face one of the greatest questions in history. Are we truly alone? Or has the universe been filled with civilizations all along, quietly evolving under distant stars? For now, the James Webb Space Telescope continues scanning the deepest darkness of the cosmos. Every image it sends back reveals new wonders. But each discovery also reminds us of something profound. The universe is far stranger, far bigger, and far more mysterious than we ever imagined. And somewhere out there, the next discovery might already be waiting, the telescope that sees the invisible. One reason the James Webb Space Telescope is so powerful is because it observes the universe in infrared light. When the universe expands, light from very distant galaxies gets stretched into longer wavelengths. This process is called cosmic redshift. Because of this, some of the oldest light in the universe can no longer be seen by normal telescopes. But Webb was specifically designed to detect that ancient infrared light, allowing it to observe galaxies formed more than 13 billion years ago, very close to the time after the Big Bang. In other words, Webb is not just looking into space, it's looking back in time, the golden mirror that changed astronomy. The telescope's mirror is one of the most remarkable pieces of engineering ever built. It is made of 18 hexagonal segments coated in gold, forming a giant mirror about 6.5 meters wide. This makes it more than twice the size of the mirror used in the Hubble Space Telescope. The larger the mirror, the more light a telescope can collect. And the more light it collects, the deeper it can see into the universe. That's why Webb can detect incredibly faint objects billions of light years away, a telescope far from Earth. Unlike most telescopes, the James Webb Space Telescope does not orbit Earth. Instead, it sits nearly 1.5 million kilometers away at a special location called the second Lagrange point, often referred to as L2. This point allows the telescope to stay perfectly aligned with Earth and the Sun while remaining in deep space. Its giant sunshield, about the size of a tennis court, blocks heat from the sun, so the telescope can stay extremely cold. This is important because infrared observations require very low temperatures to detect faint cosmic signals. Studying alien worlds, one of Webb's most exciting missions is studying planets around other stars. These planets are known as exoplanets. When an exoplanet passes in front of its star, a tiny amount of starlight filters through the planet's atmosphere. The James Webb Space Telescope can analyze this light and detect the chemical fingerprints of different gases. So far, Webb has already detected water vapor, carbon dioxide, and methane in the atmospheres of distant worlds. These discoveries are helping scientists understand which planets might be potentially habitable, discovering the first stars. Another major goal of the telescope is to observe the very first generation of stars in the universe. These ancient stars formed when the universe was only a few 100 million years old. Studying them helps scientists understand how the first galaxies formed and how heavier elements like carbon, oxygen, and iron were created. Without those elements, planets and life as we know it would never exist. The future discoveries. Even though the James Webb Space Telescope has already made incredible discoveries, scientists believe its most important findings may still be ahead. The telescope is expected to operate for more than a decade, continuously observing the universe with unprecedented precision. During that time, it may reveal new types of galaxies, unknown cosmic structures, the chemistry of distant planets, and possibly clues about the mysterious forces shaping the universe. One of the most fascinating aspects of the James Webb Space Telescope is that it is not just, in many ways, it is a time machine. When we look at distant objects in space, we are not seeing them as they are today. We are seeing them as they were when the light first began its journey toward Earth. Light takes time to travel across the vast distances of the universe. Because of this, the deeper we look into space, the further back in time we see. For example, when Webb observes galaxies that are 10 billion light-years away, it is actually showing us what those galaxies looked like 10 billion years ago. This means that astronomers can watch the history of the universe unfold by studying objects at different distances. The James Webb Space Telescope allows scientists to observe the universe closer to its beginning than ever before, approaching the era shortly after the Big Bang itself. And what Webb has already found during these early observations has surprised many scientists. Some of the galaxies Webb has detected appear to be far more massive and developed than expected for such an early time in cosmic history. According to previous models of galaxy formation, galaxies should have started small and slowly grown larger over billions of years. But Webb's observations suggest that some galaxies grew extremely fast, reaching enormous sizes much earlier than predicted. This raises new questions about how galaxies form, evolve, and interact. Did gravity pull matter together faster than we believed? Did early stars form in massive bursts of activity?